So in this question, this is a complex algebraic problem. So we've got an object M1 has a kinetic energy of E1. So I'm going to start writing these things down. So we have kinetic energy 1 is 1/2 M1 times V1 squared. Another object has a mass M2 with kinetic energy E2. So kinetic energy 2 is 1/2 M2 V2 squared. The objects have the same momentum. So the same momentum. So we know P1 is M1 V1 and P2 is M2 V2 and P1 equals P2. So in other words, M1 V1 equals M2 V2. So these are our relationships we're starting with. Haven't even read the question yet. What is the ratio of E1 to E2? Well, E1 to E2 is 1/2 M1 V1 squared over 1/2 M2 V2 squared. The 1/2s cancel and we're left with M1 V1 squared over M2 V2 squared. So now we're looking at our choices. What is the ratio? Is it 1, M2 to M1, M2 over M1, square root of M2 over M1, or the quantity M2 over M1 squared? So in this case, we look at all our choices except the first choice, A. We see that all of the answers have only M. So that means we must get rid of the V1 and V2 somehow. So we've already used our kinetic energy equations. This other thing we know is M1 V1 equals M2 V2. And notice this is V1 over V2. So if we solve this equation for V1 over V2, we get V1 over V2 is M2 over M1. And so if we wanted V1 over V2 squared, we would square the other side. So now that gives us M1 over M2 squared over M1 squared. Canceling this squared out with this M2, this squared out with this M1 gives us M2 over M1. So we can see then that the ratio of E1 to E2 is equal to the ratio of M2 to M1. And that's why this question's best answer is choice C.